me to switch on my mic. Sorry for that. Hello, everybody. This is Katja Jakob speaking. I am here sitting at the office in Jena, our headquarters in Germany. And we will provide you with the first of a series of webinars today. We will start in a minute, just give people the time to dial in. And before I hand over to our presenter today, to Torben, I would like to explain how we handle this. So this is a series of altogether 6 webinars. And the idea is that you can register for each session, so it's different links. You have been provided with the information in the sales newsletter or via email through your supervisors. We are recording these sessions, so everybody who participates can, of course, watch the recording then later on again, and you can also share that recording. We will provide you with the link afterwards, and we will also communicate this link again in our sales newsletter. Everybody who is dialed in is muted by default. When you want to ask a question, and that is always possible, please raise your hand or type it into the question form. So just take a minute and check your GoToWebinar panel, and there you have different little folders, and one is the questions form, and there we collect all the questions related to the talk, and we will have, at the end, we will have plenty of time to answer them. If you have technical issues, you can also see a little chat form. And in this chat, you can communicate with me directly. Just write to Size Academy RMS, that's me. And then I can help you. Yeah, so maybe you have issues with the audio or with seeing the slides and everything, or seeing myself and the presenter. Then I can help you with this one. Okay, and all the questions are collected, so we will share a Q&A document afterwards if we don't manage to answer all of them, so nothing will get lost. So don't worry about that. I'm sorry. Don't worry about that. Everything will be discussed. Okay, so and now I hope that my presenter is here with me. In a bit, I can still see people dialing in, so let's give it 1 minute before we start. So Andy, I already see you. You are with me. That's great. I hope you can hear and see. Okay, and I can still see people dialing in. That's really cool that we have so many people participating today. Okay. So let's see. I think we are good to go. Maybe some of you can already give me a signal if you can hear. If your audio is good, just type it into the questions or chat form. Just that we are sure that everything works fine. Great, so audio is working fine. Thanks for the feedback. That's cool. Okay, so I think we can start. I can see the crowd is almost complete. So with this being said, Torben, I would like to hand over to you. I will switch off my camera now so that we can have the full bandwidth, and Torben Wolf will go ahead with the presentation. Torben, are you ready?
I am ready. Good morning. Can you hear me?
Good morning. Yes, we can hear you loud and clear. So the stage is yours. Thank you.
Thank you. So can you also see my screen as well?
Yes, we can.
Wow, great. Thank you, Katja, for the introduction. And yeah, I'm really happy that we can have this webinar today. And welcome to that webinar about target applications in material microscopy. My name is Torben Wolf, and I'm at SAIS RMS in the business sector material science, and we'll talk about applications with light microscopes in the field of materials. For that, where is it? For that, here we are. In preparation of that presentation, I had a really great support from my colleagues Andy Holwell and Rich Taylor, who are in the business sector raw materials. So Andy is responsible for metals and steels, and Rich is the geologist. And you will hear Rich after in the end of that presentation. And what will be the presentation about in the next 45 minutes? I will talk about, at first, some introduction in this training series. Then I present some applications in engineering materials, applications soft materials, energy materials, and applications in geology. And I hope we will have some time to answer some questions that comes during this presentation. So when we talk about customers, most of our customers are interested in results and images like this. And for addressing particular applications and getting these colorful images, specific solutions are necessary. So each solution consists of a basic set of different ingredients. So at first, it's the microscope, then some accessories like objectives and camera, and the proper software. That's together is the solution for the customer. And with our powerful portfolio of microscopes, accessories, and software, it's sometimes hard to find the right setup for the individual solution. So when we come from the customer needs and their application, you see like teaching, documentation, failure analysis, measurement, multi-phase, heating and cooling experiments. It is a solution, is a mixture of software that we have, the right camera, and the most suitable microscope hardware. And the broad portfolio gives you a wide solution space. So with different combination of the single items that serves the application needs. And for example, you can do some multi-phase evaluation, very easy and rather inexpensive, with a combination of lab scope and the Primotech microscope. But the same application, multi-phase, can also be solved with machine learning-based Zen core segmentation software, high-end scientific camera, and a full-blown motorized Lexo imager. So there are needs and arguments for both configuration, but to know which would be the right configuration for a customer, to get a better feeling about that, we introduce this webinar series. So the upcoming webinars will cover these four main blocks. So the application, the software, camera, and the microscope itself, and overall the configuration of it. And that's how it looks. The timeline. So today we are here, we're talking about typical applications. And in the following weeks, we take closer looks at our software portfolio, introduce the power of our material modules. Here we get application relevance insights about our camera portfolio. And in the webinar number 5, we will see how the configuration of a typical solution look like and where you can find these pre-configured solutions in our web shop. And the week 6 gives us an opportunity to summarize our strengths of our portfolio and the solutions that we provide to our customer. So then we start with the target applications, and The first field is engineering materials, and I would like to show some typical applications. Understanding and to an extent controlling the linkage between how material is processed, the resulting structure created by that process, and then the properties that emerge and the performance we can achieve. The center of this material science paradigm is the characterization, where our solution comes into play. So processing itself is incredibly diverse, with parameters across casting, forging, rolling, drawing, annealing, and the various other typical steps, as well as early in the process with characterizing mine productivity and raw materials. And in the last few years, this complexity has increased tremendously with the emergence of additive manufacturing, where now very localized and heterogeneous effects and new alloy compositions are forcing us to think differently about how that influences the material local structure. But with the most processing conditions, we almost always create features across multiple length scales and dimensions, starting with things like surfaces or welds at the large scale, to grain structures, inclusions, multiple alloy phases at the micro scale, and precipitates dislocations in grain boundaries at the nanoscale. But the relevance of those structures depend on the usage. Sometimes mechanical properties are critical, like in transportation, where we need strength and fatigue lifetime, but also low weight and low cost. For chemical properties, like we see in naval or energy applications, we need materials that withstand tough environments and problems like corrosion. And in the medical field, biocompatibility of implants or prosthetics is dictated by a host of factors, including mechanical similarity to the host structure, the ability to incorporate new cell growth, and bio-inertness. So when we put these aspects of processing, structure, properties, and performance together, there's then at least a dozen different ways we use microscopes in understanding metals, and in both industry and academic research. And we have specific software modules available to serve various tasks for this engineering materials. So with non-metallic inclusions, you determine the cleanness of steel. Grain size analysis determines the size and distribution of grains that is linked to specific properties. And with interactive measurements and layer thickness, you measure different features in the image. The material, the cast iron material, has different appearance of its graphite particles that is sorted with cast iron analysis. Multi-phase analysis is a powerful module to evaluate the different ingredients of an alloy. And comparative diagrams is a kind of virtual wall chart where you can compare your images with a set of pre-configured standardized images. Intelligence helps you to segment challenging images with machine learning algorithms. And Zen Connect is a module for correlative microscopy that combines different modalities like anatron and light microscopes. And this GXP is a tool for regulating manufacturing processes that are likely in the pharma industry, but it can also be used in steel industry to ensure your data integrity. And these modules, more in detail, that is something what we will discuss in our third webinar in this webinar series. So where do we find these customers for these applications? We provide solutions for various tasks in the whole process, from research to development, over quality assurance, certification, to failure analysis. Our customers are in diverse fields of industry and academic facilities. So let's have a look at some images taken in the field of engineering material. So what you see here is a cross-section of an extruded aluminum alloy showing grain structures and some dots here, precipitatives here, and this one is the image in bright field, and that's the same sample in dark field where the inclusions and the particles are now really highlighted. What you can see here. This is the next example. So various material samples, what I will show, and alloys, and it uses a range of different contrasting methods we have available as light microscopy. This one is Barker etched aluminum in polarized light. That makes this really nice colors out of it. Most of these samples have been mounted, then grinded and polished down to a flat surface, and in some cases etched to enhance grain contrast. There are several companies offering high-quality sample preparation tools like Struers or Light High Tech, who produced this image shown here on magnesium with the axial vert microscope. And this material is bell bronze, which differentiates from normal bronze in that it has somewhat higher amount of tin. And the increased tin makes the alloy more rigid, which is what provides the acoustic properties appropriate for a bell by creating a strong resonant vibration when it is struck. And the classic application in engineering materials or metallography is the inspection of spherolytic or nodule-shaped graphite particles within ductile cast iron. These tend to inhibit crack formation and give the material more impact and fatigue resistance than other forms of cast iron. So the image shown here is with polarization and with an additional lambda compensator element, so giving this striking color you see here. Graphite and iron can take numerous forms. So this one shows vermicular graphite, where now the graphite particles have flake shapes rather than nodules. This casting type is referred to as gray iron or gray cast iron, and it tends to have more brittle mechanical behavior. To distinguish and to sort this kind of cast iron, we have this materials module, cast iron.
Interrupt for a second. I'm sorry.
Yes.
Your voice is breaking up back from the group. It's not just me. So
Okay.
can you adjust the micro or change the headset?
Yeah. So is it better now?
Yeah.
Okay, good. I will. Sorry for that.
That's again very soft.
Okay. Sorry for that. So I will.
Maybe you can use another headset or something.
No, that's not possible. I will. Is this okay now?
Yeah.
Okay, so I have to have it here. Okay, good. Thank you for that feedback.
Okay.
Good. So sometimes we also look at finished parts like this, and that have been shaped into some particular geometry. And this one is a stainless steel bolt made of a duplex steel, which you can resolve as the difference between the white face here and the more colorful face. It was cut and polished to show here the cross-section of the microstructure at the edge of one of the threads. Segmenting these two phases in the microstructure can be challenging. For this, we have segmentation tool based on machine learning. It is called intellisis, and the general application for intellisis is where there are two or more phases or materials or types that need to be accurately separated. You need information about one or the other. So it could be particles in the matrix, clusters of one phase in another, certain layers, certain regions. And the power of intellisis is that once it is trained on a certain type of image, you can reliably segment many more similar images. So in this slide, it demonstrates 5 examples with intelligent segmentation on each. So the training of the model took only a maximum of 5 minutes in each module, in each case. So for engineering materials, you will find all the stated applications like teaching, documentation, multi-phase segmentation, non-metallic inclusions. And in the 5th webinar of this series, we will go a little bit deeper into the certain configuration for each of these applications. So let's continue to another type of material, and it is about soft materials, and today's examples are from the world of plastics and polymers. So polymers and chemicals have applications across many industries. Some of the polymers applications are clothing, textiles, and fibers, automotive and aerospace, communication, films, engineering resins, cosmetics, paints, pigments, and adhesives. So the main applications are failure analysis, process optimization, and fundamental research. Research is focused on performance improvements and novel processing to improve efficiencies and lower the production costs. For light microscopy is used in polymers and chemicals research to improve and observe processes such as composition, fiber splitting, or 3D printing. It is used to analyze and obtain desired microstructures, phase distribution, crystallinity, and porosity, and in order to obtain polymers and chemicals with desired properties, for example, like that is reliable and cost-effective, or you can also recycle it. Very, very nice. So in light microscopy, we have this analysis in layer thickness measurement, where you can easily make measurements of the layer here, microstructure analysis, failure analysis as well, and some phase quantification where you can see which phase belong to which kind of ingredient of the material. One really interesting thing is the behavior of plastic at different temperatures. Here you see on the left side a plastic foil that was stretched by hand to create some strain. And in the video, you see the strain manifest in cross-polarized light with multiple colors. As the plastic heats up, as you see here, as the plastic heats past the melting point, you can see the strain leaves the material and then becomes transparent. As the temperature drops back down, the material reappears but without strain. Our microscopes can be equipped with this kind of stages. This is linking heating and cooling stages. They can be controlled directly from our software, and your customer can easily create in situ temperature experiments with Zen Core. That's a really nice application. This carbon fiber enhanced plastics is a widespread compound plastic material. In this thin cut, we see layers of carbon fibers from the top and from the side. Whilst in transmitted light bright field, everything appears okay. Insertion of a polarized light with a lambda plate discovers the inner rupture of the material. It's actually stated here in this purple color. And here we see the structure of a carbon fiber reinforced polymer. The different direction of the carbon fibers are nicely displayed in this cross section. And this is polyamide, also thin cut. Normally they have nice spheres, but these have melted during the embedding sample preparation process of the sample. And that's something what we can see here really nicely in polarized transmitted light as well. So again, for plastics and polymers is also a wide range of applications possible. we will introduce in the webinar number 5 some configurations for heating and cooling experiments, and also a versatile configuration with polarized light in transmitted and reflected light microscopy. And for the next field of material that we would like to discuss are energy materials. Research into a wide range of energy generation and conversion technologies is helping to provide clean energy to today's society. Batteries are a big part of that technology portfolio, but also fuel cells and solar cells are getting more attention in research and industry. Next to the green energies, there's still a demand for nuclear technology with new techniques and materials. But the main focus in industry and research is nowadays the batteries. Before we take a deeper dive into the battery itself, it makes sense first to look at some of the motivating factors one step deeper at the industry level. We can easily identify 4 major design criteria listed here. The real challenge is in this whole scenario that these factors are all interrelated, and it's really tough to change one with affecting the others. For example, costs is an obvious factor driving both industry adaptation for consumer and consumer demand. But decreasing the cost without decreasing the reliability or efficiency is really, really difficult. Similarly, in the electric vehicle market, range is a clearly major factor, which basically comes down to energy density of the batteries. But when you get down to the cell and electrode level, energy density and power density have somewhat different demands on the cell chemistry and microstructure. So it's a balancing act. And for safety, after recent high-profile cases like Boeing Dreamliner battery fires and the Samsung phones, there's really no leeway tolerated in the market in terms of compromising on safety on these devices. But how does the lithium-ion battery looks inside? So it is a system of several layers inside here. You see that cut of that lithium battery. And the system describes the anode, the separator, and the cathode. And knowing the microstructure helps to understand and predict the performance of a battery. And as the ingredients are very reactive with air, the sample preparation needs a closer look. So careful sample preparation is essential here, not only for safety consideration, but in order to ensure that the results of our investigations are accurate and reflected the inherent microstructure of the sample. The basic approach.
Torben, is there anything we can do about the audio?
No, not really. So
it's really we understand only every second word, so that's kind of difficult. Maybe can you try to work on your bandwidth and close everything which is communicating with the internet?
Yeah, I can do.
Okay. Sorry, guys.
Yeah, sure.
This is a new
I'm
today.
Always something new.
Yeah.
So I closed everything.
So let's try again.
Okay.
Okay. Thank you so much.
Okay, good. Yes, thank you for the feedback. So, yeah, when you prepare the sample, you need to use this kind of glove box in a argon environment, so that the ingredients will not get into fire. And yeah, and you can use a specific polished cell here, or alternatively, you can install the whole light microscope inside this kind of glove box. And there are a lot of different battery characteristics you can observe and analyze with a nice light microscope. And the images here show some of those through an analysis of a large-scale prismatic cell that was opened, sectioned, and prepared for light microscopy analysis. Details of particle size distribution, intraparticle defects like cracking and porosity, layer thickness variations, electrode layer cracking, and impurity distributions are visible and easily accessible across very large areas. And not only you can do manual inspection for defects using light microscopy, but the results can be combined with image segmentation and classification algorithms that utilize machine learning to automate defect characterization work and create powerful, high-throughput workflows for battery analysis. Another example for energy material are magnetic materials. With a specific polarizing setup, using the Carrot effect, it is possible to make magnetic domains visible with a light microscope, as you see here. And yeah, this is an image of a lithium-ion battery with a large area scan with several tiles stitched together to get an overview about their battery structure. And yeah, finally, for that section, we have the Carrot effect that shows these really nice, striking images of the magnetic domain. So here we are again, the applications that are relevant for energy materials. So, and coming back to the final application, field of application, that is geology. And in this section, Rich Taylor from the business sector raw materials will tell you some basics about geology. This one is a recorded webinar here for the next 10 minutes, and I would like to play this webinar. And Katja, please give me just a short feedback if you can hear the sound of it. So that's something you should hear now. Do you hear something?
No.
Okay, so so now I need some help how to get the audio. Okay, I will try this again. Katja, can you hear something now?
No.
Okay.
Would it be possible to make this available as a movie to the people who are dialed in?
Yes, sure. That is something what it is available in Widen.
Mm-hmm. Okay, so what I can do then for everybody who is participating today, together with the slides of today, I can share with you also the link to this one so that you can find both material and watch it later on. Would that sound like a plan?
That sounds good. Yeah, good.
Mm-hmm.
This is great. So I'm very sorry that we could not show this because Rich is doing really great job in that presentation here, talking about some what a geologist is doing, some special names and fields of applications, what you see here, and also some basics about polarized microscopy. And it's worth to look at this presentation as well. Okay, so there are also a lot of applications in geology available for this kind of light microscope, and yeah, we will talk about the configuration itself in the fifth webinar, as I stated before. And before we open the Q&A session, I would like to thank you at first for your attention and for your time. And sorry for about the microscope of the my microphone, bad audio. And I will give you a short outlook about the next coming webinars. So next week, we will have a webinar together with Roger Landolt and Konstantin Schade, where we talk about our software landscape and how to use software as a differentiator. And I'm happy to see you there again. And now I would like to open the Q&A session if there are any questions.
Okay, cool. So let's look at the questions. One thing we can do from our side is we can do this first part provided by Torben. We can do a little recording there so that you get the proper quality of Torben's nice voice and not the issues we had today. We are tremendously sorry for this. We will definitely find out the reason why that happened and provide you with something that you can take benefit of. And also, of course, the link to this webinar from Rich. So what questions do you have? Please put them into the questions form or raise your hand, and we are happy to answer them. I think I give people a little bit of time so that they can enter their questions, or raise hands. That's also fine. Just let me know what would be better for you guys and we will help. Let me quickly check if I see raised hands. Not yet. I'm really happy that we have some of our partners, size partners in this call. So that's really great to see you. Some of the names I'm pretty aware of, so welcome. Okay, so let's start with the questions. Torben, ready to go? First question is from Mohammed. Can you give me a short note about welding inspection?
A short note about welding inspection. Okay. For welding inspection, we have one solution in ZenCore, and so there is an interactive measurement. You can do the measurements like distance, angles, and radii, and one specific tool is the so-called A-throat measurement, and yeah, that's incorporated in the welding, in the interactive measurement, and you can do it with a microscope.
Okay, what else do we have? We quickly check.
Hi, this is Andy Holwell from the metals sector in RMI. Yeah, I just thought I'd add to that really. I mean, weld analysis obviously is a big key metals topic. So within like microscopy, you're looking at a lot of different things. So the welded region of any metal or intermetallic sample would be a heat affected zone, and that changes the morphology of the grains within those layers. So you will typically have the parent material, the weld material, and then this intermetallic or sort of either heat affected zone between those two layers. So there's a few things. So the interactive measurement, and there's a nice application note on doing that. So merely the size of the weld, for example, the dimensions of the weld. You might also want to look at layer thickness analysis. So you may want to look at the thickness of that heat affected zone in that weld. And of course, if you think about Intellisys, then a segmentation of that the morphology of that heat affected zone can be quite difficult, because you've got different phases going on because of that heat treatment, different shapes and texture within those grains. So Intellisys can be used as well, and we've got 1 or 2 examples of that in the separate Intellisys decks. And I think Torben, it was the first example in Torben's metals examples before. So there's a lot you can do with welds, and there's a lot that our customers want to do, want to understand beyond just grain size and layer thickness. And of course, EDS and EBSD in particular, moving into the SEM world, EBSD is a particularly interesting way to characterize those in terms of the crystallography. So there's lots of different ways to look at weld analysis, and it depends on the customer requirements. Thank you.
Okay, so that's the question. Thank you, Andy. And just stay in case there are more questions that
yes, of course,
also relate to you. Wonderful. So that was the weld analysis. Then the next one is again one from Mohammed. Also different between micro and macro inspection, and which microscope for which test.
Oh, that's
a complex. That's a wide field, right?
It's a wide field question, yeah.
Yeah, I mean wide.
Yeah. It depends on the application. When you say macro inspection, micro inspection, yeah, it's about some of the inspections. If you want to see if there's a part already on your sample, or if something. I want to see if something is there or not. Maybe it's a macro inspection with a stereo microscope. But if you want to go more into detail in the microstructure, you need a compound microscope for that. So maybe you can specify it a little bit more to get an appropriate answer.
Mohammed was just asking for a short note, but maybe we can also add to the Q&A follow-up some links to other training material that we have for these kind of questions. Yeah, so because there is training material available on our learning platform where you have access. Yeah, so we will pick up some of the courses for you, Mohammed, and for the others, and add the link. So yeah, that you can have a look at this. Then next one is from Xiam. This is, please provide some info on clinker microscopy. Actually, never heard of clinker microscopy. Do you know what?
Lincoln microscopy, maybe.
No, clinker like with a C. Xiam, can you specify that a little bit? Maybe give us some idea about applications. So Ben is helping out. Here's it's a type of concrete, so like cement, for example. It's a specific industry. Clinkers are meant in raw materials. Thanks, Ben, for your help, and also thanks the others for jumping in.
Yeah. Yes, we do have some customers who are using our compound microscopes to get to look at these building materials like clinker, cement, and so on, and where we want to see in thin cuts how the structure of it is. It is, and we can get some information out of it. So this is something what we can do with that microscope setup, whether, for example, an Axiolab or Axiscope. But if there's a specific evaluation, like a specific result numbers or something like that, that's something we need to discuss more.
We also have Ben
there
in
is,
the call.
There is an L3 presentation as well on Widen. So I'm not a specialist on it. I know that the materials, the advanced materials side of the industry team have done a concrete and cement L3, which has got some of those topics in it. I'm not very familiar with it, but I know it's on Widen.
Yeah. So we also have Ben in the call. So Ben, maybe you can also give some of your thoughts here.
Yeah, can you hear me?
Yes, we can.
Okay, great. Yeah, so yeah, clinker. So it's a pre-material for making concrete, and there is a level 3 presentation on this it's called Advanced Building Materials on Widen, where we do an analysis of light microscopy and electron microscopy using the case study of the self-healing concrete, and then there's also something called concrete cancer, and those 2 case studies are used in the L3 presentation.
Okay, so Ben, I would say we also link this document then in the follow-up.
Yeah, it's particularly important in the Middle East because a lot of the buildings in the Middle East are made with seawater due to the cost of desalination. And so, yeah, it's a real problem about damage to buildings, particularly in the Middle East.
Okay. Good. Took a note about this one. Thank you. And Ben, maybe you just mute and unmute yourself in case you want to add something else. Okay, so we have a little bit of time left for more questions. Anything else we can answer for you? So far, I cannot see any more questions. Okay, so maybe Torben, can you maybe show again the overall slide with the modules, 6 different webinars that we offer? And then meanwhile, before we talk about this again, Andy, maybe you can answer one more question that I just received about Intellisys feature. Can you elaborate a little bit on this?
Yes. So, I mean, segmentation is really the reason to do optical or any imaging these days. I mean, segmentation is the biggest problem and challenge and opportunity for metals and material analysis. So it's the good images can be got from anywhere really, but it's the data and the information that Intellisys can bring, which is a step change. So again, there are application notes and other materials on Widen about this, but a traditional segmentation may be best based on grey level thresholding. It's a bit of a blunt instrument in that for something like a dual phase steel, a ferrite and pearlite or ferrite and martensite steel, it's usually quite effective. It usually will give you a nice multi-phase split between ferrite and the second phase. But where traditional segmentation can be flawed is if sample preparation is imperfect. For example, if there are scratches, for example, it may mistake a grain boundary for the second phase. So typically, you might see a nice bright white ferrite phase in a steel micrograph, but the second phase, the darker phase, could be the pearlite, or it could be a grain boundary, or it could be an inclusion, or it could be an impurity or something on the sample itself. So Intellisys is able to provide, it's sort of the best of the human eye and the best of the computer eye, if you like. So it brings that little bit of guidance and training from the human eye, because we know that if we see 2 ferrite phases with very different texture, it's still ferrite, but it may not be recognized as that within the traditional segmentation software. So Intellisys, it's uniquely easy to use. Machine learning is a hot topic within lots and lots of particularly academic work, but it's easy to forget that a lot of the traditional machine learning segmentation that's been done in those settings involves coding, and it involves a lot of sort of very, very expert knowledge. And where Intellisys is a step change is that it's completely intuitive. You draw on your sample image, exactly what you want the program to interpret, and then you can use that model, that trained model, retrain it if you need to, and then apply it to many different images. So segmentation, it's really about segmentation and taking out those imperfections in that automated segmentation, the dumb machine, if you like. So we've shown in we've got an applications note showing different metal samples, different material samples, even like 3D foam materials as well, beyond the metals realm. So there is an application note on that, and we found a few percentage difference in the segmentation given with Intellisys than a traditional segmentation. Finally, what I would just say is we now have, we call it Intellisys Inside sometimes, in a reference to Intel Inside, I guess. All of our materials modules are now Intellisys equipped, with the exception of NMI, which is a project that's ongoing. So that will be complete as well within a year. And the user has an option to go through a traditional segmentation process, very important, for example, for ASTM grain size measurement, for example. But you have the opportunity and the option to go through an Intellisys workflow within those materials modules. So it brings that power of Intellisys into the materials modules themselves. So yeah, it's very flexible, very intuitive, and I think it is a step change in how, not just in segmentation, but also how machine learning is applied to materials analysis. So I hope that helps. We've got an L3 on Intellisys, by the way, for metals, and there are various materials as well, but please ask us. We can always provide the latest materials. I think you're muted, Katja.
That will be the sentence of this year, 2020. You are still muted. Sorry for that. I had some background noise. That is why I muted myself. Thank you so much for this one, Andy. Since we now have the slide in front of us with all the modules, let's just quickly make sure that everybody knows what is coming ahead. As Torben already said, this was the introduction into target applications. Next time we will focus on send core and lab scope positioning. So this is in 1 week, always 2 sessions per day, one fitting to, from our point of view, to the eastern part of the globe, and one fitting to the western part of the globe, to the respective time zones. So everybody should be able to participate. And after each meeting, we will provide the recordings. For this one, we will make sure we do a proper one of Torben's part. And then you can study the material again. And of course, you have our contact data, and you can email us in case you need anything else. And with this being said, I would say thank you for today. Thanks for participating. Thank you so much, Andy, Ben, and Torben, for helping us here, presenting everything, and answering questions. And everybody stay safe and stay healthy. Goodbye, everybody.